This is the last lecture in quantum mechanical series, and today I shall discuss in part 4 2p orbitals in detail. For this 2p orbitals, n equal to 2, n equal to 1 and n equal to -1, 0, +1. So the wave functions are psi 2px, psi 2py, psi 2pz, and in terms of this quantum number, this is psi 2px equal to psi 2 1 1 bar, psi 2py equal to psi 2 1 1, and for psi 2pz equal to psi 2 1 0. All these three p orbitals are degenerate and having the same energy, and the energy is equal to minus 1/4 mu e to the power 4 divided by 2 h cross square. The angular momentum of each orbital will also be the same, and L equal to root over L into L plus 1 h cross, and L equal to 1 here. So this angular momentum equal to root over 2 h cross. It is the same for all these three p orbitals. But Lz for this 2pz, 2px, but the z component of angular momentum is equal to mh cross, and m is different for different orbitals. This Lz for 2px equal to minus h cross, and for 2py it is h cross, and for 2pz equal to 0. And we know this Lz determines the orientation or alignment of this angular momentum vector. So this is the, suppose this is the z axis, and here lies this nucleus at the origin, and this one is the L, the angular momentum vector, and this one is the z component of L equal to this one, this value, and theta is the angle between this angular momentum vector along with this z axis. So Lz equal to L into cos theta. For psi 2px, cos theta equal to Lz by L, and Lz equal to -1 and L equal to root over 2. So theta equal to 135 degree. That means the angular momentum vector aligns at an angle of 135 degree with respect to this z axis. And this psi 2py, for psi 2py, cos theta equal to 1 by root over 2 and theta equal to 45 degree, and for psi 2pz and cos theta equal to 0 and theta equal to 90 degree. Means for 2pz orbital, for this 2pz orbital, this angular momentum is perpendicular to this z axis. The wave functions of 2px, 2py, 2pz are given here. R sin theta cos phi equal to x, and this is why it is named as 2px, and here R sin theta sin phi, it is y, and so it is 2py, and R cos theta is equal to z, so it is psi 2pz. A, the normalization constant, and it is found same for all these three orbitals. So this normalization, now I shall discuss the 2px orbital. For this 2px orbital, the normalization constant could be obtained by this way, by this normalization condition, all space modulus square of psi 2px theta equal to 1. And putting this value of psi 2px and square up, and then d tau equal to r square dr sin theta d theta d phi, then this integration comes up a square 0 to infinity and e to the power minus r by a naught and r to the power 4 dr, and 0 to integration 0 to pi sin cube theta d theta, and 0 to 2 pi cos square phi d phi equal to 1. This integration, first integration, is 24a05, could be done very easily by using this gamma function. And this one little bit complicated, but its value I shall show later on. This one is 4 upon 3 and this is the pi. So putting all these values here, this a is found to be 32 pi a naught to the power 5 whole to the power minus half. So normalization wave function for this 2px orbital is 32 pi a naught to the power 5 whole to the power minus half e to the power minus r by 2a naught and r sin theta cos phi. Now I am coming to the shape of this 2px orbital, and wave function is given here, and if r sin theta, it is better if we convert these expressions of this psi 2px in terms of this Cartesian coordinate. Then r sin theta cos phi equal to x, and for r square equal to x square plus y square plus z square. If we consider the z axis, then y and z both are equal to 0. In that case, r square equal to x square along this x axis, and so r equal to modulus of x. So psi 2px could be written as a is the normalization constant e to the power minus modulus x by 2a naught and x. If we plot psi 2px versus x plot, then 0 to plus infinity right side, in this right side x is positive, so psi 2px is also positive. And not only that, here is the non-exponential term, here is the exponential term. With this increase of x, this one is increasing, but this exponential term is decreasing, so it is a Gaussian distribution. So this psi 2px starts from 0, attains maximum, and then decreases to 0 when x equal to plus infinity. Whenever we are considering this 0 to minus infinity left side, then x is negative, so psi 2px is also negative. So in this case also it is a Gaussian distribution. Exponential term, non-exponential term, both are changing in opposite direction. There someone is increasing, then other one is decreasing. So this one will be like this. So if we like to have a concrete shape of this 2px orbital, then we can rotate up by 360 degree along this x-axis. Then we shall get one lobe 0 to plus infinity and another lobe 0 to minus infinity. This lobe is positive and this lobe is negative, and it becomes a dumbbell shape. Nodal plane is the yz. Yz is the nodal plane for this side, for this 2px orbital. And this, whenever we are plotting this psi 2px square probability density, then a square, it will be square up, and it will be 2 will vanish, e to the power minus modulus x by a naught, and it is x square. So since it is this x square, so whether x is positive or x is negative, x square is always positive, and so psi 2px square probability density is always positive on both sides of the x. So whenever we are plotting the psi 2px square versus x, then again we are getting this Gaussian distribution. With rise of x, with increase of x, this one is increasing, this one is decreasing, but increasing very rapidly. Here it is x, here x square, so this psi 2px square will increase more rapidly and falls also very quickly. Here 2a naught, here 2 is vanished. So the right hand side also will be like this one, and whenever we are rotating this x-axis by 360 degree, then it becomes a dumbbell shape. And dumbbell shape, and both sides will be positive, and the nodal plane will be along this yz, nodal plane yz. So this will be the contour surface of this orbital, and it is becomes a, when it becomes a dumbbell shape along this x-axis. So this electron cloud density or the probability density is oriented along this x-axis, and this shape is dumbbell shape. Now I shall discuss one very important aspect of this 2px orbital, and it is the radial probability distribution function, or simply a radial distribution function PR. And PR is defined as the probability of finding this electron in a spherical shell of radius r and thickness dr is unity. And this one is obtained, this dr is obtained by integrating this side to a 2px squared d tau over all the angles of theta and phi, but not over r. So this dr equal to theta 0 to all range 0 to pi, and phi 0 to 2 pi, and modulus square of 2px and d tau. Modulus square of 2px into d tau. So putting this value of a sine 2px a square e to the power minus r by a naught r to the power 4 dr, and this one 0 to pi sine cube theta d theta, and 0 to 2 pi cos square phi and d phi. So this value a square equal to 32 pi a naught to the power 5 whole to the power minus 1, and e to the power minus r by a naught, and it is r to the power 4 dr, and whenever it is integrating, this one is 3 by 4, and this is 4 by 3, and this one is pi, and altogether we are having this 24 a naught to the power 5 whole to the power minus 1, and e to the power minus r by a naught r to the power 4 dr. So PR equal to dr cancels, so PR equal to a dash into e to the power minus r by a naught r to the power 4. PR again I may say that it is the probability of finding this electron in a spherical shell of radius r and thickness unity. When PR is plotted against r, this starts from this origin r equal to 0, so PR also equal to 0, here r to the power 4, so PR rises very steeply, very rapidly, and attains maximum and then decreasing, as it is also the Gaussian distribution function. So since with increase of r, this r to the power 4 will increase, but this exponential term will decrease. So this Gaussian, as by nature of this Gaussian function, it will start from 0 and increases and attains maximum and then decreases to 0 when r equal to infinity. We can also calculate the radius of the spherical shell at which this PR attains maximum. So for that, the condition is that dPr by dr, this is the condition of extrema, and it is equal to d by dr a dash e to the power minus r by a naught r to the power 4 equal to 0. If we do this differentiation, then this r max will be equal to 4 a naught. Means when this we consider a spherical shell of radius 4 a naught at which of unit thickness, at which the probability of finding this electron is maximum. We can also calculate this expectation value of r R means radial distance, means position distance of this electron from this nucleus, and this average value of R or expectation value of R is equal to all space integration psi to px r cap psi to px d tau. Again d tau we all know, r square dr sin theta d phi, and psi to px when we are putting here 32 pi a naught to the power 5 whole to the power minus 1, and it is 0 to infinity e to the power minus r by a naught r to the power 5 dr, and it is 0 to pi sin q theta d theta, and here it is 0 to 2 pi cos square phi d phi. This value, this first integration could be done by using this gamma function, and this one could be obtained by, I will show later on, this one will be 4 by 3 and this is the pi. So altogether, whenever all these three integrations are given here, this expectation value of R means radial distance from this electron from this nucleus is equal to 5a naught. This definitely proves that there is a definite chance for this electron to be found in a spherical shell beyond of radius of beyond 4a naught, since average distance equal to 5a naught greater than 4a naught. And if we calculate this x average value of position along this x-axis, then it will be all space psi to px x cap psi to px d tau, and x equal to r sin theta cos phi. Whenever putting this value 32 pi a naught to the power 5 equal to the power minus 1, 0 to infinity e to the power minus r by a naught r to the power 5 dr, and this one 0 to pi sin to the power 4 theta d theta, and it is 0 to 2 pi cos q phi d phi. But this last value of this last integration is equal to 0. So x average value of x equal to 0. This is obvious that the 2px orbital is oriented along this x-axis equally to be found plus x and minus x from this origin, and so average value becomes 0. Now I shall show the integration 0 to pi sin cube theta d theta. This integration is a little bit complicated, and so I do here in a very simple way. And integration 0 to pi and sin cube theta means sin square theta and sin theta d theta, and sin theta d theta equal to minus d cos theta, and sin square theta equal to 1 minus cos square theta. So when you are doing this integration, minus 0 to pi and d cos theta and plus minus plus, and 0 to pi cos square theta and d cos theta. And whenever putting this integration, minus cos theta 0 to pi limit plus 1/3 cos cube theta 0 to pi limit. Whenever putting this limit, I can get this first term is 2 and second term 1/3 into minus 2, and altogether this two sum of the two values becomes 4 by 3. Now I shall discuss this 2p y orbital and 2p z orbital. All these two orbitals having the same characteristic features as this psi 2px. Only the difference is that in this case the electron cloud density is oriented along this y-axis, and in this 2pz orbital it is along this z-axis. So I can discuss it in a brief way. The wave function is a into e to the power minus r by 2 n and r sin theta sin phi. R sin theta sin phi equal to y. So y and r, as I have done in previously, instead of r I write here modulus of y and a into e to the power minus modulus of y by 2a naught and y. And a is the normalization constant and its value is like this. Whenever I am plotting this one, whenever I am plotting this psi 2py along this against this y-axis, then it becomes again the Gaussian distribution, and it goes like this, starting from this 0, it is increasing and then decreasing to this 0 value when y equal to plus infinity. And in this case, whenever it is 0 to minus infinity, y is negative, and so this psi 2py is also negative, and it is also Gaussian distribution will go. If we like to get a concrete shape of this 2py orbital, then this to be rotated along this y-axis by 360 degree. Then we shall get this two lobes. One lobe, right lobe is positive, left lobe is negative, and it will be like a dumbbell shape. If psi 2py square, if we plot along this y, and this one equal to a square e to the power minus modulus y by 2 by a naught and y square. And in this case, so y square is always positive. Psi 2py square is also positive. This one positive, this one positive. Whenever this one is rotating, then it will give the electron cloud density or probability density like a dumbbell shape and oriented along this y-axis. And it is the nodal plane, and nodal plane is the xz. For this 2pz orbital, the same features, psi 2pz equal to a into the power minus r by 2a naught r cos theta equal to z, and this one r equal to modulus of z. And this plotted, whenever plotting this psi 2pz versus z, then it will be positive from 0 to plus infinity, and negative 0 to minus infinity, and again it is rotating by 360 degree. It gives a lobe, right lobe positive, left lobe negative, and like a dumbbell shape. If psi 2pz square, if we plot along this z axis, then psi 2pz square equal to a square into e to the power minus z by a naught, and here z square always positive, so it is both sides having the at a definite value of z, the probability density will be fixed, same. So if we again rotate this one along this z axis, then we shall get this lobe, and this lobe is oriented along this z axis, and it is also dumbbell shape along this z axis, and nodal plane is xy. If we do this three orbitals in the same curve, it is x-axis, it is y-axis, it is z-axis. So 2px orbital, in case of 2px orbital, the electron density is oriented along this x-axis. In case of 2py, along this y-axis, and 2pz along this z-axis. And this is all about, in short, for these 2p atomic orbitals, and the the probability and radial distribution function and other terms r and z or x will be the same as I have done in case of 2px orbital. So thanks to you all who are watching this video, and please subscribe if you like so. In my this is the last lecture of this quantum mechanics. Henceforth, I shall try to give lectures on the thermodynamics and in mixed up Bengali and English. Okay, thank you all.